Hey, this is Robert Naini, your spray foam advisor, and today we're going to share some guidance on the proper design and installation of hybrid systems in southern climates. These concepts are based on guidelines developed by SPFA, published in SPFA 146, using a series of hygrothermal analysis completed by a consultant assuming several different failure criteria. We're going to focus on the design of hybrid insulation systems within the building envelope with the intent to target code-required R values and minimize the potential for condensation and air leakage in wall cavities. As previously discussed, a hybrid insulation system uses a thin layer of spray foam to reduce air leakage and provide a portion of the total R value, and then adds fibrous insulation to provide additional R value and thermal performance. Generally, the SPF is installed in the cavity first, against the exterior sheathing, and the balance of the cavity is filled with another type of insulation, which could be fiberglass bats, blown-in fiberglass, rock wool, wet spray cellulose, dense packed cellulose, another type of spray foam insulation, or even reflective insulation. Now, when using hybrid insulation systems, we will generally be concerned with a few key items. First, the climate zone. Different climate zones are going to require a different approach to these hybrid insulation systems, so we have to take that into account. Also, according to the International Building Code, in climate zones 1 through 3, interior vapor retarders should not be used. So in southern climates, we're typically not going to have an interior vapor retarder in that assembly. Now, another component that's important is the total R value, specifically the total code-required R value for the installation for that wall cavity. And another component of R value is the minimum spray foam R value required for condensation control based on climate zone and related also to the total cavity R value needed. Now, finally, the interior humidity and temperature conditions also play a factor here. The biggest risk with hybrid insulation systems is the potential for condensation. Now, we must start and have some assumptions somewhere in the process to even be able to make an analysis of these designs. So we typically begin with typical operating conditions for residential homes. Now, unusual occupancies with higher relative humidity or larger temperature differentials, or even special designs like pool areas or cold rooms, will require additional analysis. So don't take these methods and apply them to special circumstances. If it's special circumstances, then you're going to need special analysis or some type of additional analysis, maybe even a hygrothermal model like a Wolfe analysis specifically for that approach or for that design. Now, overall, the key question to worry about with hybrid applications is, what is the minimum recommended thickness of spray foam to minimize the risk of condensation in this design? So it takes into account this specific design, in particular the climate zone and what you're trying to accomplish. So there are several key factors that determine the minimum recommended design thickness for these hybrid applications. In climate zones 1 through 3, the design thickness should be determined by looking at a couple of key thicknesses, and we're going to choose the greater of these thicknesses. And SPFA identifies for closed cell foam, we want a minimum of ½ closed cell foam or a minimum of 2 inches of open cell foam. So those are the minimum, absolute minimum requirements per SPFA and their guidance in the SPFA 146 document. Now, moving on, we also need to know what is the minimum thickness to qualify that product as an air impermeable insulation. Because remember, what we're trying to achieve with these hybrid applications is we're trying to get the air barrier with the first thin layer of foam, and then we're trying to add to the balance of the R value by adding an additional insulation material. So what is the minimum thickness to qualify as an air impermeable insulation? The next is the minimum recommended application thickness for the product. And then the final category we want to look at is 17% of the total installed R value. Now we look at these four categories, and our intent is to select the greater thickness amongst these four categories because this will be your recommended minimum design thickness for your hybrid application. Let's take a look at an example of a hybrid application in climate zone 2 like Houston, Texas with an R13 wall requirement. Upon discussion with your SPF supplier, you discover that both their closed cell foam and open cell foam have been tested as air impermeable insulations at approximately 1 inch thick. Furthermore, they tell you that their closed cell foam has a minimum recommended thickness per pass of 1 inch, and their open cell foam has a minimum recommended thickness per pass of 3 inches. And finally, 17% of the installed R13 equals R2.2, which would be less than ½ an inch of their closed cell foam and less than 1 inch of their open cell foam. So by reviewing this table, you can quickly see the greatest thickness for each product. In this case, 1 inch of closed cell foam or 3 inches of open cell foam. In this part of the country, climate zone 2, most walls are made of 2x4 wood studs, which gives us a cavity space of approximately 3½ inches thick. So trying a hybrid application with 3 inches of open cell foam doesn't make much sense, does it? You might as well just fill the cavity with open cell foam while you're there. Now, on the other hand, you can apply 1 inch of closed cell foam in this cavity and fill the remainder of the cavity with another type of insulation and have very little risk of condensation in this climate zone. Now, while this is a standard way to approach a hybrid insulation application, as with any application, make sure the path that you are taking meets local building code requirements. And additionally, remember that the minimum recommended design thickness is going to be dependent on the specific SPF products you're working with. So consult your supplier or review their technical documents to answer the questions previously discussed to make sure you are using the right thickness of the products you are working with. This has been Robert Naini with Spray Foam Advisor. Thanks for checking us out. Catch us on some more videos.